It's hard to say with precision its edges or estimate its total magnitude. Nevertheless, thanks to the James Webb Space Telescope, we now have the ability to glimpse into the most distant parts of the universe. Since its launch into orbit, countless researchers, including Brian Cox, have shared insights that unveil the vast scale and sheer immensity of the universe, a realm that nearly defies human understanding. In the segment of the cosmos that is observable to us, scientists estimate there are approximately 2 trillion galaxies. This is based on studies conducted in our local region, and it's widely believed that this observable zone is just a minuscule piece of what could be an infinite universe. We've yet to fully realize that we are not only one with the universe, but are actually an essential component of it. In a poetic sense, through us, the universe becomes self-aware consciousness. With the James Webb Telescope lighting the way, we begin a remarkable journey to uncover the actual extent of our universe. If you're passionate about keeping up with astronomical breakthroughs and space-related updates, consider subscribing to our platform. Make sure to like the content and activate notifications. Picture traveling at 70 mph to circumnavigate Earth's equator. It would take you nearly 360 hours. To reach the moon would take 15 days. Getting to Mars at its closest point would demand around 63 years, and astonishingly, reaching Neptune would require close to 4,400 years. These figures alone emphasize the enormity of our solar community. To supply some perspective, let's look at Voyager 1, a space probe launched in 1977 that traveled at approximately 38,000 km/s. Despite its rapid speed, it didn't exit our solar system's expenditure for 35 years, simply to depart our local space environment. That demonstrates how enormous even our immediate cosmic surroundings are. Even light, which can circumnavigate the globe 7 times in a second, seems surprisingly slow when contrasted with the immense scale of the solar system. And yet, as vast as our solar system is, it's tiny compared to the Milky Way galaxy. The Milky Way contains an estimated 300 billion stars, many potentially surrounded by their own planetary systems. Our closest stellar neighbor, Alpha Centauri, is about 4.3 light-years away, which equates to, even traveling at the speed of light, it would take more than 4 years to achieve. But if you journeyed at Voyager 1's pace, it would take an incredible 70,000 years to arrive. That clearly demonstrates the staggering distances in interstellar travel. Consider a star named Rho, situated 64 light-years away. If we reflect on the idea of the radiosphere, the region through which Earth's radio waves have traveled over the last 100 years, these faint signals have reached approximately 15,000 star systems. Yet, this is a mere drop in the ocean compared to the total number of stars in our galaxy. When you gaze at VY Canis Majoris in the night sky, you're witnessing light that left that star over 640 years ago, well before Columbus embarked on his voyage to the Americas. It's astonishing to realize that this beam of light has traveled for centuries before arriving at our eyes. To illustrate the scale of our radiosphere, imagine shrinking the solar system to the size of a coin. Centered there on the same scale as us, the Milky Way would cover all of the United States. Within this colossal region, there are 300 billion star systems, each likely hosting planets of their own. We are just one among those billions, drifting in an unfathomably vast ocean of stars and worlds. Looking beyond our galaxy, there are at least 1 trillion more galaxies. Yes, a trillion. That's a number so large, it's hard to truly visualize. Imagine 1,000 cats. Now imagine 1,000 such groups of 1,000 cats each. That makes 1,000,000. But to reach a trillion, you'd have to multiply that million by another million. An astronomical concept, literally. The Andromeda Galaxy, which is our nearest galactic neighbor, lies about 2.5 million light-years away. It's swiftly approaching the Milky Way, and when they eventually meet, the night sky will look drastically different. Andromeda contains around 1 trillion stars, while the Milky Way holds approximately 300 billion. Even with that difference in mass, The odds of two individual stars crashing into each other during the merger are incredibly low, highlighting the vast spaces between stars. Though galactic mergers are rare, they can spur the birth of new stars and even fresh galaxies, possibly laying the groundwork for new life. Galaxies aren't static. They evolve continuously. As we peer further into space, we first find our local group of galaxies, followed by the Virgo cluster, home to over 2,500 galaxies. Virgo is part of a broader structure called the Laniakea supercluster, containing nearly 100,000 galaxies. Each galaxy is home to hundreds of billions of stars and planets, and this still only accounts for a sliver of the universe that can be observed. It contains an estimated 10 million superclusters, such as Laniakea. As we zoom out, we find more and more mapped galaxies, yet the known ones are just a small representation of what actually exists. Hundreds of billions remain undetected and unmapped. Also worth noting is the cosmic microwave background radiation, the faint remnant light that originated in the Big Bang and is the oldest visible light that exists. It provides vital clues about the early universe. The universe's size increases in awe-inspiring ways when we consider cosmic voids, vast stretches of space where matter is significantly less dense and stretches across hundreds of millions of light years. They appear almost completely empty, yet they may one day form new cosmic structures and galaxies. As we delve deeper, we come across cosmic filaments, massive threads of gas, dust, and dark matter that span billions of light years. These filaments form a cosmic network that holds together galaxies and clusters through gravity, creating an intricate, large-scale structure. Within these webs, galaxies continue their gravitational dance, colliding, merging, and evolving. The universe provides an infinite stage for marvels like supernovae, the catastrophic ends of huge stars that disperse heavy elements across space, introducing black holes into future star systems. Due to the immense gravitational pull they exert, black holes profoundly influence galaxy formation and can emit energetic jets that stretch significantly beyond their host galaxies. We discover far-flung reaches of the universe, quasars, enormous black holes devouring matter and radiating unbelievable energy. These brilliant objects can outshine entire galaxies and provide information about the very beginning of the universe's development. But the mystery remains. What exists beyond the observable universe? Countless galaxies lie out of view because their light hasn't had enough time to reach us. Moreover, because of space's continual expansion, the light from some galaxies will never reach us. These realms may forever stay out of our scientific reach. Through observational models based on physics, estimates suggest that the full universe is at least 250 times larger than what we can currently observe. Some hypotheses even suggest that it's infinitely large. This broader understanding prompts us to reflect on the true essence of the universe and our role within it. We humans, residing on a tiny planet in a boundless cosmos, are an integral part of this vast, awe-inspiring universe. Constantly inspired to contemplate our purpose and place in the grand narrative, have you ever paused to wonder just how immense the universe truly is? I hope this video has provided a new perspective on the vast scale of the cosmos. Feel free to leave questions in the comments. If you found the content interesting, like it, share it, and subscribe for more fascinating material. Thank you for joining us, and we look forward to having you join us on our next journey through space. The universe is beyond what we can fully grasp. With every breakthrough, especially those enabled by tools like the James Webb Space Telescope, we catch fleeting glimpses. Despite the fact that our day-to-day lives are rooted on Earth, understanding the cosmos gives our lives a broader, more meaningful context. We're a small species on a small planet in an unimaginably large and intricate universe. When we mention the observable universe, we're only touching the surface. There's far more waiting outside of our reach, and every new discovery stretches our comprehension just a little further. Knowing that there are galaxies so far away that their light hasn't reached us and never will raises important questions about our future. As space continues expanding, vast regions of the cosmos will remain inaccessible forever. Additionally, this expanding universe signifies endless possibility. With every step forward in discovery, it reshapes our view of reality. Predictions hint that the universe might be 250 times greater than what we currently perceive, or even infinite. Such ideas compel us to rethink our existence. Exploring the cosmos isn't merely philosophical and scientific. Each star is a fragment of a much larger puzzle. As we decode the stories of stars, galaxies, and cosmic structures, we become clearer about our place in this vast system. While our comprehension is still evolving, each advancement brings us closer to grasping the full magnitude of existence. These revelations also challenge us to consider what lies ahead. If the universe truly has no boundaries, then the possibilities for exploration are endless. Could humanity one day travel beyond our own galaxy? Will we explore systems far from home? These questions remain central to our quest for knowledge. It's important to recognize the role of technology, particularly instruments like the James Webb Space Telescope, in driving these discoveries. Without such innovations, much of what we now understand about the deep universe would continue to be a mystery. With every image captured and data point analyzed, we get closer to understanding the fabric of the cosmos. Although space exploration is a colossal challenge, it brings equally monumental rewards. As we continue this journey, may we always keep our minds open, motivated, and united in the pursuit of cosmic truth. As our understanding deepens, one truth becomes more and more obvious. The universe is not static but dynamic, ever evolving, and constantly in motion. Stars are born and die, galaxies collide and merge, and black holes silently reshape the structures all around them. At all times, cosmic events occur at unimaginable distances, some so violent and powerful they warp space and time itself. Take gravitational waves, for example, like ripples in the fabric of space-time, predicted by Einstein and only recently observed. These waves are generated by massive objects like black holes or neutron stars colliding, and their detection has opened a new window into the universe. Through them, we can now listen to cosmic events, not just see them, fundamentally altering our study of space, offering us new clues about the early moments of the universe and the nature of gravity itself. Meanwhile, dark energy and dark matter continue to be the most fundamental cosmological mysteries. Together, they make up roughly 95% of the universe, yet we cannot directly observe them. We infer their existence through gravitational effects and the universe's accelerating expansion. Dark energy, in particular, is believed to be the driving force behind this expansion, pushing galaxies apart at an increasing rate. Understanding these components could revolutionize physics and challenge even our fundamental assumptions regarding reality. Our quest to understand the universe also leads us to the search for life beyond Earth. With thousands of exoplanets discovered, many of them located in the habitable zones of their stars, we now know that Earth-like conditions may be far more common than previously imagined. Advanced telescopes like the James Webb are already analyzing the atmospheres of these exoplanets, looking for chemical biosignatures, traces of life like oxygen, methane, or water vapor. Though we have yet to find definitive evidence, the mere possibility fuels our curiosity and imagination. Even closer to home, our solar system still holds secrets. Moons like Europa, Enceladus, and Titan are believed to harbor subsurface oceans, and missions are underway to probe their environments. If microbial life exists in these alien seas, it would suggest that life is not a rare accident, but a natural consequence of planetary evolution. Such a discovery would rank among the most important in human history. Meanwhile, humanity's ambitions stretch farther than ever. Plans for crewed missions to Mars are progressing, with multiple space agencies and private companies working toward landing humans on the red planet within the next decade or so. Creating a sustained human presence on another world is no longer the realm of science fiction. It's becoming an engineering challenge. The lessons we learn from living on Mars could pave the way for even more distant journeys in the future. At the heart of all this exploration is a shared sense of wonder and the need to comprehend where we fit into the grand scheme. Space compels us to look both outward and inward. It humbles us, reminding us of our smallness in the cosmic scale, but also empowers us with the knowledge that we are capable of comprehending vast, ancient, and complex truths. No matter how far we go, the stars will continue to inspire poetry, art, science, and dreams. The night sky is a living archive of time, each star a historical record glowing across ages. Some of the light we see today began its journey long before the first human civilizations rose. In a way, looking up is also looking back into the universe's deep past and perhaps into our future. As we continue to probe the cosmos, it's important to remember that our journey is just beginning. We've barely scratched the surface of what there is to know. With every advancement, we uncover more questions than answers, but it's this endless curiosity, this drive to seek and understand, that defines our species.